You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem.
Good morning, good afternoon, and good evening wherever you are, and we are coming to you from Boston, Massachusetts. Today is June 28th, 2024. Hope everyone is doing well and staying safe. Can't believe it's almost the end of June, end of 6 months. I remember when we started this year, we had the New York Times a platform architect on the pod for an episode, and we were talking about this year we want to bring in more practitioners to talk about their experiences with Kubernetes. Looking back 6 months, that hasn't panned out a lot. We still had a lot of vendors on. It turns out it's easier for vendors to talk about their products and the challenges and how they solve things than practitioners to talk about their internal details. But today we are back to the practitioner approach. We have Brandon Jacobs from Coreweave, which is an AI hyperscaler, and he'll talk about how they have built their entire cloud platform based on Kubernetes from the beginning. So I'm excited for that discussion. Before we dive into the actual episode or actual interview, let's cover a couple of news items that caught my eye. The first one being Ollama. I know Ollama, we have spoken about it a few times on the pod as something that we used to run. I personally use it on my laptop to run LLM models. So like if you want to download Llama or any other open source LLM models like the Google Gemma model or Microsoft Phi, you can download it from Ollama and run it locally. Wiz Security actually has a new CVE which allows an attacker to send specifically or specially crafted HTTP requests to an Ollama API server. The CVE is CVE 2024-37032. They actually have an interesting name for it called Problema, I guess, play on words. But again, the blog that we'll share in the show notes included that as soon as Wiz shared the vulnerability with the Ollama folks, they jumped on it, resolved it in 4 hours, and there's a patch that's available. So if you're running and haven't updated Ollama in a while, make sure you update that if you're running LLMs locally. Next up, we have another acquisition in the Kubernetes ecosystem. So a couple of weeks back, I think SUSE had their annual conference, SUSECon, in Berlin, Germany, I think. And they announced there that they acquired an observability platform called StackState. The eventual plan is to integrate StackState and all of its end-to-end observability capabilities into Rancher Prime. But with everything that SUSE does, they also are planning on open sourcing a version of StackState so that it's available for users to use without having to pay for licenses. So that's cool. StackState, what is it, right? StackState is an observability platform that automatically discovers and maps dependencies between all your different components. So like all your different containers, how they map to Kubernetes nodes, how they map to like cloud resources, other infrastructure services. So they've built all of these integrations to give you a complete picture. So it would be pretty cool, like once they integrate it into the Rancher Prime platform, like from that single pane of glass dashboard, you can visualize how your apps or how your clusters are doing and how they map to like the cloud resources or infrastructure resources that you might have underneath it. So something to look out for later in this year. That's the timeline, I think, for Rancher Prime integration and also open sourcing a version of StackState. There was no price being disclosed. And honestly, like I didn't know StackState as a startup or as a company. So this was news to me. Congratulations to everybody there. SUSE is a great company who's always innovating for their customers. So a good company to be a part of. With that, I think I'm ready to introduce Brandon and start the interview section of the podcast.
This episode is brought to you by our friends from NetHopper, a Boston-based company founded to help enterprises achieve their cloud infrastructure and application modernization goals. NetHopper is ideal for enterprises looking to accelerate their platform engineering efforts and reduce time to market, reduce cognitive load on developers, and leverage junior engineers to manage and support cloud-mandated upgrades for a growing number of Kubernetes clusters and application dependencies. NetHopper enables enterprises to jumpstart platform engineering with KAOPS, a cloud-native, GitOps-centric platform framework to help them build their internal developer platforms or IDPs. KAOPS is completely agnostic to the Kubernetes distribution or cloud infrastructure being used and supports everything including EKS, GKE, Rancher, OpenShift, etc. NetHopper KAOPS is also available on the AWS Marketplace. Learn more about KAOPS and get a free demo by sending them an email to info@nethopper.io or download their free version using mynethopper.com/auth.
Hey, Brandon, welcome to Kubernetes Bytes podcast. I'm so excited to have you on the pod. I know Coreweave does a lot of interesting things, but I recently learned from you that they use Kubernetes under the covers. So I want to talk more about that. Let's start by having you introduce yourself quickly, and then we can dive into what Coreweave is and how it uses Kubernetes.
Yeah, that's awesome. Yeah, thank you for having me. I'm glad to be here. My name is Brandon Jacobs. I am an infrastructure architect here at Coreweave. I've been at Coreweave for a little over 2.5 years now. And if you're not familiar, Coreweave is an AI Hyperscaler cloud. We build purpose-built application, the platform for AI companies, people doing really large AI workloads at scale. I am primarily responsible for building out our Kubernetes backend, which is run on bare metal and is different from other clouds. And we believe that that is what gives us a more performant and efficient version of cloud infrastructure for AI.
Awesome. I like the AI hyperscaler thing. I think I saw on Twitter somewhere that, or X maybe, you guys filed for not a patent but a trademark for the AI hyperscaler. So it looks like you got it. That's awesome.
We did. Exactly.
And you be working on building out the infrastructure using Kubernetes makes you the perfect guest to have on, because we have had vendors and we have had practitioners, but we don't have anybody who has built Kubernetes at this scale. So I'm excited to have this conversation. So we already covered what Coreweave is. Let's talk about why you ended up choosing Kubernetes, because from what I know, Coreweave is newer than the AWS's, the Azures, right? So did you always start with Kubernetes or did you modernize to Kubernetes?
Yeah, it's a good question. So I joined around 2.5 years ago. The transition from what Coreweave originally started out as, just working with GPUs in a garage, to deciding to become a cloud started about a year before I joined, right? So within that year, we had always started with Kubernetes. Our founding engineers, our CTO, VP, from the beginning, we recognized that Kubernetes was the tool that was going to get us to where we needed to be, right? It had so many things from the ground that why would you rebuild it? And, like you had stated, Coreweave is a newer cloud, right? We are the new kid on the block when it comes to the hyperscalers. So when you look at that, we weren't, held to the same restrictions that other people had 20 years ago, right? That didn't have all these things. So we didn't have to use, hypervisor layers and build our own orchestration tools. So it was a huge win from that, right? And plus the Kubernetes ecosystem is incredibly diverse. There's so much support out there and it's a known tool. So it makes adoption so much easier when what you're building is what everyone else uses and it's just a common platform, and with that, right, we've been able to take that and become one of the largest providers of H100 GPUs on the planet, right, which is incredibly powerful. And we also build some of the most, some of the biggest supercomputers on the planet, up to 32,000 GPUs under single InfiniBand fabrics, all powered by Kubernetes, which is really incredible.
That's awesome. You already said the biggest GPU cluster. What scale are we talking about when it comes to Kubernetes, right? I'm sure like any other cloud or hyperscaler, you have different regions, but then how do you manage Kubernetes, or what's the biggest Kubernetes cluster that you have?
Yeah, so we've got tons of clusters currently, right? Our first Coreweave, the legacy Coreweave that we call it, which is really funny to say 2 years ago, our original Coreweave cluster was about 6,000 nodes across 3 different data centers. And that's a little unheard of. Most people don't want to run Kubernetes across regions. And we could tell you why, right? Obviously, you have the heartbeats from the nodes have to talk back to the API server unless you distribute your API server in etcds, and then they'll tell you don't run etcds across region because there are issues with that, right? And consensus. So there are a number of reasons why you don't do that, but we made it work, right? When you're a scrappy startup, how do you give access to flexible compute to customers who who really need that, right, on demand. These, 2 years ago, we were, bringing in customers who just at the tip of the AI revolution, right? Like they didn't know what they needed. People, Stable Diffusion came out, or like these like GPT, 2.0, like all these things are just starting to come out, and people are like, who knows how popular they're going to be. So we needed to have that flexibility, and it was really powerful, and it worked. And we had a lot of lessons we learned from that. But now we run, very performant, isolated training clusters, inference clusters, anywhere from 1,000 to 5,000 nodes. Like I said, 8,000, 32,000 GPUs, all under single fabrics, which is really incredible.
Okay. So are your customers coming to you asking for Kubernetes clusters, or they don't really care about the infrastructure? They just need access to GPUs to run their workloads?
I think it's both. What we find is that these AI labs, right, they are extremely competent. They know what they're doing. You get some that have a very particular way that they run, because a lot of these companies already have on-prem clusters, or they have clusters in other clouds. So they have very specific ways that they like to run their Kubernetes clusters, or they have very specific requirements. And we have our own opinions, right? Because we've been doing this a lot. We have, certain settings that we like to apply. We have certain, things that we install, and sometimes they don't mesh. But what we find is that all these customers like care about is the performance, right? So, and what we differ for how we offer Kubernetes is we include what we call batteries included Kubernetes. Our managed Kubernetes offering includes a lot of the things that most managed Kubernetes doesn't give you, right? Usually you get a control plane and that's it. And here you go, right? You have to upgrade the masters.
Yeah, figure it out.
Exactly. And we take a lot of that off the plate. We pre-install a lot of the things that, the GPU drivers, the health check verification systems, we call that our mission control, right? So it's not a black box. And that's one of the biggest differences. Our Kubernetes is as crystal clear to us and the customer. So we get notified of issues simultaneously with the customer, and we always are able to say, hey, your node just went offline, or it's less performant than it needs to be. We're gonna swap this out, right? And that's kind of the key difference. Is it's not here's your cluster, have fun. It's like it's a living, breathing organism that we co-parent, right, and keep it alive. And that's really like what's really different and interesting about how we do it.
No, that's definitely interesting, right? So like giving that extra layer of manageability to the customer and monitoring the cluster on behalf of the customer as well. Do you see this more in lines with, I don't know if you have been paying attention, like at Microsoft Build last month, Azure announced like AKS automatic, and GKE has this autopilot version of Kubernetes cluster deployment as well. Does Coreweave standard look like one of those services where it's more managed?
I want to say somewhat, right? I'm not too familiar with those because I haven't had a chance to go play around with those offerings as much. But I will say that our managed Kubernetes, right? I like to say it's kind of a combination of the control plane and the data plane, right? For example, we have a very specific setup for the CNI. We have a very standard CSI that we pre-install, right? That's performant for AI ML style workloads, right? It's a specific NFS client. Like there's all kinds of things that we do. And most of the time customers have to do that themselves, right? Like, like I need to set up a node feature detector. I need to set up node problem detector. You don't have to. We pre-bake everything. We pre-install Prometheus. We pre-install your monitoring systems. Obviously some customers have very specific requirements of like, hey, I want to send it to Datadog. I want to send it to, to this external platform or Grafana Cloud or something, right? And obviously like we have the ability to, work with them, and you can do that as well. But, sometimes you just want to focus on what you care about, which is your application development, your model training, your inference. So what we do is we say, okay, here's a cluster. Everything's in it that you need. Here's how you look at the observability stack. Here's how you deploy your stuff. You're good to go, right? That no one needs to touch anything else. And I think that's really the beauty of it, because we can take someone from onboarding into a cluster, getting the nodes online, and go into production in 2 weeks for a 500,000 node cluster. And that's very common. Like we can get 1,000 node supercomputer online in 2 to 3 weeks. Minimum.
Wow. Okay. That's awesome. That's crazy to think about, like that scale. Okay. So when we started this discussion, you said you deploy Kubernetes on bare metal. So when customers are requesting for Kubernetes clusters, are they getting these bare metal Kubernetes clusters? Or we were also talking to, like on a previous episode, we spoke to the CEO of Loft Labs, and he implied that Coreweave also uses vCluster technology. So like, how do you leverage that? And is that obvious to the end user?
So yes, so we do have some work we've done with vCluster. The vCluster components are a separate offering, separate thing that we use for. A lot of the clusters that we're deploying today are strictly bare metal nodes, bare metal clusters, containers on bare metal, right? Like straight performance, straight to the host. The one of the key things that makes this possible for bare metal Kubernetes in our environment is that we leverage NVIDIA DPUs for network isolation, network security, which means that we're able to provide, cloud-based, VPC security, right? Just like any other cloud, except we don't have to do hypervisor layers or anything like that. We just do straight host level isolation, which is great, right? Because with supercomputers, sometimes you have to get onto the host. You have to see like, what is happening with my mount to storage, or what is going on? Like, why is containerd messing up? Or like, why is the GPU, NVIDIA SMI, for example, why am I getting, corrupted output on my training job? Like, and it gives the customer a chance to dig in, because they obviously, a lot of people have that expertise. Like, we have people in-house who are good at ML, good at understanding the customer's problem space, but like, we're not AI labs. It's like, we don't, so it's a lot of give and take for them, identifying problems, we learning from them, and then us updating our stuff to help them. So, it's a living relationship. And I think it's actually really, really helpful for how we do that.
Interesting. So, like when you're talking about having access to those physical resources, right? There is no level of multi-tenancy that Coreweave does. Like, you give them access to these nodes with Kubernetes and everything installed on top of it. And then the customer can decide if they want to use the different like GPU sharing algorithms, like time slicing or vGPUs, all of those things. That's left to the customer.
Yeah, absolutely. We, historically, Coreweave has never found a need to do GPU fractionalization or time slicing, because we've always had such a large array of GPU SKUs to offer, right? Historically, we'd started with like RTX 5000s, ATX 4, we had all these different sizes, right, that could fit, 8 gig models, 24 gig, 48 gig, and then we got the A100. So we had, you're fitting 40 gig, 80 gig models on, so with that, right, traditionally, people only had one GPU type, right? So so in order to like make it worth your money, you had to split it up, right? Because you didn't need the whole thing, but we never had to do that. So we would always just tell people, hey, just choose the right size GPU for your workload. So we prefer not to do that, but obviously in this environment, there's nothing stopping anybody from doing that, right? So if you want to run a system like Run AI, or anything else that does that stuff, it's totally possible. It's well supported, and they can do that. But lucky for other people, they don't have to if they just want to request certain GPU types that meet their need.
Yeah. Okay. No, that makes a lot of sense. Like you were talking about installing like the node discovery plugins and those things that on top of your Kubernetes cluster. I've done that in the past, and for first timers, it can get tricky. Like, it's not the most straightforward thing. So I'm glad that you guys are solving it for the customer. From an underlying provisioning perspective, right? Like, how do you handle GPUs? Like, do you have different types of nodes, or based on what the customer is asking for, you use those to create a cluster? How does that work?
Yeah, so obviously, like any cloud, we have instance types, right? We've got our core CPU types that people can, will get in their clusters that run, what we call core critical services, like you would in any cluster. You got core DNS, you've got your, if you're running Calico, you've got Typhus or the kube controller, or if you got Celium, you've got Hubble, like, so all that stuff, right? You've got some nodes that need to run those things, obviously, and obviously customers have CPU compute needs as well, that they don't want to be running on GPU nodes, because a lot of times people might take up the whole host, like with just a few containers. So you got CPU instance types, and then when it comes to GPUs, right? I can't speak to the specific instance types. I'm not going to like go into the details, because I'll leave that to the sales guys and the or those people. But we obviously, as new GPUs come out, we're like, we just announced GB200 in the future. We've been doing H100, so customers will come and say like, hey, I want H100 nodes, right? We've got an instance of an H100, or lots of instances of H100s, and then we have a whole set of our company that's focused on the hardware, the life cycle, because GPU nodes are not, set it and forget it. These things are, supercomputers do not stay up for more than 2 weeks. Like, I think Jensen said that from what I remember someone telling me. But so when you think about this, right, a Kubernetes cluster with hosts like this do not just stay online once you deliver it, right? It is a constant thing of making sure that the node is healthy when you get the node, right? You run it through checks. You make sure that it's from the vendor, it's even okay. And then it goes online, and then you have to actually run it through, your provisioning checks. But then it's constantly after that, you have to keep checking it, right? Because these things will potentially break. And it happens with each new model, right? It's just like a car. Yeah. Right. Yep. Like the first model of a car is always going to have some things. It's going to get replaced. The second version is always going to get better. So, so being first is always fun because we find all these things, but it makes us better. So we're able to identify the problems. We get faster at, fixing it, getting the customer back online. So, but in terms of getting the node, it's a very straightforward process. We're working on building out, all the standard auto scaling, logic that you might want for GPU nodes as well. So, it's a very standard feeling on our Kubernetes as you would as any other cloud as well.
So what let's say I'm an AI lab who requested for 1,000 node cluster. What happens when 5 of my node fail in 2 weeks? Do you have hot swaps available, or when you run out of capacity, that's it, you'll have to wait for some time?
Yeah. Usually we do have hot swap capacity available, but it's not 100%. But that's something that Coreweave works with you individually to make sure that that's possible, right? So if obviously with 1,000 node cluster, if you need 1,000 nodes, we wouldn't be very smart if we only had 1,000, right? So we try to make sure that we have the right capacity for the right customers at the right time. Obviously if sometimes there are shortages in capacity and it takes a while, but for the most part, we always guarantee that our customers have the capacity that they need to run to their required amount.
Okay. So let's go back to the day zero, right? You said people are requesting these huge clusters. What does your automation stack look like? I'm sure people are not manually logging into each cluster, each node, and then installing kubectl and configuring using kubeadm. How do you set up these large environments? What does day zero look like?
Yeah, so we've spent a lot of time building a lot of custom operators in Kubernetes. One of the cool things is I've actually seen this be an interesting shift in the space last year or so is Kubernetes on Kubernetes. Yeah. Right. We've been doing that for 3-4 years now. Because when you look at it, right, what is Kubernetes great at? Oh, it's great at orchestrating. It's great at running containers. It's great at taking all that complexity away. Okay, well, how can we use that to run Kubernetes? So you think okay, we run control planes in Kubernetes, and what that means is that we're able to build custom operators. We're able to build all the standard tooling that leverages, metrics exporters and all the other things to monitor API servers, to monitor etcd. We've been fortunate to build our own etcd operator. That's a whole other topic. That's a very fun space. I'm actually excited to talk about. Hopefully this year at KubeCon, we'll see how that goes. Okay. But yeah, right. So it makes that space so much easier from a day zero perspective to be able to manage via operators, and we're a big KAOPS company. Right, Argos. So internally, we do a lot of that for our infrastructure. But on top of that, right, so that's kind of the easiest way for me to say what day zero looks like, right? And then our hosts are, we've worked for the last 4 years to build out our own, baked OS that has everything we need, right? Like I was talking about with the GPU drivers, all the optimizations,
interesting.
It's just there. It's just ready, right? So we're able to just get nodes online into a cluster in about 30 minutes, give or take. And obviously when a control plane comes online, a customer requests a node's going to boot up, and a node's going to come online in 60 seconds, just like any other cloud. But if you're talking about when a node gets unracked from the vendor, right, obviously it goes through checks and gets booted up, but it's the same thing. It still maybe take just a few minutes because we have our systems, completely the same for anything in all of our data centers. And it's really great because there's no snowflakes.
That's true. I think having that custom OS, which is standardized, has everything installed, definitely saves up time during the initial configuration, right? Is this something that's open source, like the AWS Bottle Rocket thing, which is their custom OS? Okay.
No, it's not open source. It's, and it's also not anything super secret, right? Like it's just, think of it as a very opinionated, like packaged thing that just, does everything we think it needs to do. And,
Gotcha.
for what we're meant to do.
Yeah, and I think when you're dealing with scale, it's important, right? You have a golden image somewhere, and then everything just gets imaged with that. And then if there is an issue, what version different nodes are running, and that becomes easier to fix.
Absolutely,
So.
yeah.
Okay.
You find that, at scale, one minor change can really make an interesting difference, especially when people are looking at performance from like, the GPU utilization levels or like the temperature something runs at, or, if a sysctl setting changes, inherently, but like, or a kernel version update, like it's, NFS driver changes. Like it's amazing what some of these customers will be able to tell and notice that you didn't think would be a big issue, but is. So it's really fun when you start looking at it like that from that.
Gotcha. So let's you brought up GitOps, right? Let's dive into that a bit. So let's say I went to the Coreweave portal. I don't have an account yet, but maybe I should. Like if you have a free tier. But then if I request for a cluster, that kicks off, let's say, an Argo CD pipeline. What does it do to get the cluster ready? Like if you can share any details there.
Yeah. So I mean, we have a number of things that we do to kick off and provision, right? Obviously, our clusters are pretty isolated to the individual sites or regions that they're in, because with supercomputers you don't really do supercomputers across availability zones or across site, right? So our model is kind of like, if I wanted one in California, right? You would be in the California. So we have some global tooling that would then take those requests and then filter it out to the proper region and then go and provision the control plane within that data center. And then once that control plane is online, right, that would then trigger some GitOps magic to provision all the applications and all the things, all the data plane components, right, that we talked about, right? This CNI, the core DNS, all those things, and get those up and running, right? And then boot in your initial nodes that you need to run that stuff, right? Because every cluster needs, one or two worker nodes. Because, like I was saying, because we run Kubernetes and Kubernetes, your master nodes are not nodes. Your masters are containers, which means so theoretically, in Coreweave Kubernetes, when you go to do something like kubectl get nodes, you wouldn't have any nodes because your masters are not nodes in your cluster. They run outside, right? Which is great from us from a management perspective, and it also takes some of the complexity away from the customer. Like they don't need to worry about it. Like it's fully managed, but it does require us to boot in initial worker nodes, right? Which is just part of what we do and what we how we offer a control plane for a customer.
No, that's super cool. Like provisioning control plane nodes as containers, that definitely speeds up things and it makes it more resilient, right? As you said, you use Kubernetes and Kubernetes, so those control loops kick in whenever one of the control plane nodes for the customer goes down. So that's awesome.
Yeah, the resiliency piece is really a fun story here, right? Because when you talk about containers and being able to do things like rack affinities or availability zone affinities, and just obviously a container spin up time is so much quicker than saying, oh, I lost a master node. How do I we don't have to deal with that. It's just, okay, let me reschedule this and state will just be fine. So it's really great.
So what does day 2 look like, right? So when I've dealt with other hyperscaler based Kubernetes clusters, upgrades are definitely the biggest pain, but it also includes like AMI refreshes. I'm specifically talking about Amazon. It also means that I have to back up or protect the applications that I'm running. What does that look like in like a GPU world? What are the day 2 operations, and how do you handle that?
Yeah, it's a good question, because there's a lot of differences with the GPU side, the GPU clusters compared to normal clusters, right? Obviously, you have the same requirements when it comes to Kubernetes upgrades and keeping the kubelet versions in, within a certain range. So, but one of the nice things is that, we manage that for the customer in a sense that, right now, because GPU clusters, you can't just take them offline. Like we're not going to be like, hey, we're going to upgrade your cluster. It is a coordinated effort, but let's say the cluster needs to do an upgrade, right? We need to upgrade firmware, we need to upgrade a GPU driver, or we need whatever, right? Obviously, as long as there's nothing running on those GPU hosts, the nodes get marked as needing upgrades, and whenever they become available, we just run them through the upgrade process, right? And it's just seamless to the customer, right? Like the node just gets updated, uncordons, here you go, right? And it's just one of those things that we have processes for from our automation side that do it. And then our support and our solutions architects, work with the customer to make sure that they're aware of when this is happening. And,
Gotcha.
and that's kind of one of the key things, right? It's, we have it as hands off as it should be, but at the same time, these aren't clusters and these aren't environments that you can just say, hey, we're updating your cluster in 5 minutes. Good luck, right? It just doesn't happen. These are extremely sensitive, large clusters that people are paying money for to do groundbreaking work. So we take a little different approach, but we also take the complexity away from the customer. As long as they approve it, we roll through it and it just updates, right? With control plane, we just roll the control plane's rolled, and then you just start rolling the nodes, and it just, we just update it.
Okay. Now, I think that kind of has to happen that way, right? Because all of these training jobs are weeks long, if not months long. So you can't just pull the rug from underneath them and say, like,
Exactly.
I need to update the version. So, okay, that's interesting. What about other day-to operations? Like, do these training jobs need to be like checkpointed? Do you help with that? Or like, what are other operations that customers end up asking you about?
Yeah. So, so a lot of our customers are really smart about this stuff, right? Everybody has their own methods for how they do checkpointing, for how they do training jobs. And we're not going to pretend we're the experts. We do have a small team that are focused a lot on stuff like that, and they're really smart. I'll give an example. We've actually given some talks about this before. We have an open source project called Tensorizer, which is related to the ML space to basically allow you to, I think, correct me if I'm wrong, I'm not an ML engineer. I think you tensorize the weights of a model and allows you to stream it directly into GPU memory. So so it really speeds up. And this is really used for inference, not training. But just to give you an example, like we have teams that are focused on optimizing that type of performance. So for the inference side, right, we'll work with customers and help them integrate Tensorizer, which means that for inference style workloads, they can go from, let's say a pod spin up time would take 2 minutes, because that's how long it takes to download the container, right? Because most people will put the weights in the container, et cetera, et cetera. But Tensorizer, basically you just put the weights in object storage and then it just downloads it directly into memory, right? So if you start optimizing that way, we can get container spun up in 15 seconds.
Oh, wow.
Right?
Okay.
So when you talk about auto scaling, like we focus on making things fast, efficient, and scalable. And the same for training as well. But, so it kind of all depends on the use case. But yeah.
And when you mentioned the 15-second boot up time for container, you actually meant like a 70B Llama 3 model, not just a random Nginx container, right?
Yeah, exactly. Something with, 20, 30, 40 gig model weights. Like these things are so like, you're talking about like really pushing like downloads and, and historically, like having large containers is not ideal because, because it's not fun to wait for a container download and you can't really speed that up a whole lot. I mean, there's a few things you can do, right? Like there's some things we can do from the container D level and all that other stuff, but I would prefer not to.
Gotcha. Okay, and you led us on a good path, right? Like talking about open source projects, not just the ones like Tensorizer that Coreweave built, but I want to ask you about like what are the different open source projects or homegrown tools that you use for different layers, right? Storage, networking, authentication, monitoring, observability. How do you handle all of these things?
Yeah, so obviously Coreweave does have a number of things we built in house, but a lot of it's based on the the kube builder, the operator SDK operator framework, right? So we have a lot of operators we built since we are Kubernetes native. We find that to be extremely useful and valuable for how we like to do operations. But in terms of open source, right, our Kubernetes and the things we run in Kubernetes is basically what you would find in any on-prem installation, or basically if you walk into KubeCon, it would be like that whole row of things. You'd probably see that. So I'm talking like we run vanilla K8s, right? Obviously we with certain settings, but we run vanilla K8s and we run traditional, etcd, cert manager, external DNS, metal LB, Calico and Cilium, node feature, node device, kubevert, core DNS. So really like we run a lot of the standard things that people would expect to run in Kubernetes. And what's great about that is that by us running that, not only do we run that, internally and in our managed offerings, but like, when a customer comes to us and, they're familiar with that product because the world's familiar with that product, right? Like it's not like we're doing anything special. And it also means that the debugging efforts and when bugs come up or when there's patches and they like we can all speak intelligently about like what the system's doing because we all know. And I think that's really what's key, right? Because like what we're delivering is, these large clusters that are focused on, performance and scale for AI ML workloads. Why should we spend the time, why should a customer spend the time debugging something that's, proprietary in a cluster when that's not what they're trying to do? So, and also don't reinvent the wheel. Like we're not here to reinvent the wheel on some of this stuff. We're here to deliver maximum performance, for what these companies need to deliver.
Okay, no, I agree with that, right? Like, don't reinvent the wheel. If people have put in years worth of work developing these standards, developing these things, so why try to do it on your own? So you brought up one of the projects as KubeVirt. So can you talk about how you use KubeVirt, and do you also have like a VM infrastructure as a service offering where people can request a VM and that uses KubeVirt? Like, can you talk more about that?
Yeah. So historically, obviously, like I said, Coreweave runs bare metal Kubernetes, right? That is inverse to how a lot of people run Kubernetes on clouds, right? So to get around that, right? When we started out, right, a lot of people, weren't doing distributed training yet. A lot of people weren't, you had a lot of researchers and people who needed VMs because that's how they're used to, right? That's how a lot of people are historically used to running compute. So in order to meet those requirements, we ran KubeVirt, right? In the past, we have our own set of custom operators and tooling that our cloud allows you to create VMs with a number of other things, but it's all powered by KubeVirt on top of bare metal Kubernetes, which is great, right? Because you can come in and ask for a VM with 500 gig ephemeral root disk. You can say, attach me a public IP, give me 4 extra volumes, right? You can bring your own OS, you can bring your own image, obviously all that other stuff, right? And you can spin up a GPU workstation in like a matter of a minute, which is really great, and it's been extremely powerful in the past. What we're seeing now, though, is there isn't a huge ask for that now because of what these companies are doing, right? They're doing multi-node, GPU training jobs, or you're talking about scale inference, and VMs just don't give you that. That's what Kubernetes is better at. Is like that's what Knative's for. That's what all these like systems are for. So we can support that. KubeVirt has been a great tool, and I think we're going to always continue to have that, in our stack. But we're not seeing that be the ask right now. We're just seeing for like, okay, how do I get 32,000? How do I get 64,000 GPUs? How can I have it's just getting larger and larger, and VMs aren't going to cut it.
I love that statement. VMs are not going to cut it.
No.
So Brandon, like one question, like this is a storage focused podcast, right? And I always had this, and since you do this on a day-to-day basis, for these AI labs, what kind of storage do they expect? Like, are they expecting block storage, file storage, or everything is just object in the AI world?
It's interesting because it really depends on the company, right? I think everyone has their own flavor of what they like. Some people are all about object. Some people are all about, shared file system, NFS. Others love having their block, right? When it comes to distributed training, you can't really get away from having like local checkpointed files on the node itself, but you have to back it up somewhere, right? Whether that's whether it's a networked file system somewhere, or if it's object storage somewhere. And we have a storage offering that is a network attached storage, right? It's NFS. We have a partnership with Vast, so we and others, but we also have our storage team is amazing at optimizing for extremely high throughput, workloads, because you can't imagine what it's like when you have 1,000 nodes trying to download a file, or like it's pretty crazy, right? And I'm not on the storage team, so I'm not going to speak too closely to what they do on a day-to-day basis, but it's pretty incredible some of the requirements some of these people have, and just like some of the things that we have to do to get to that point.
Gotcha. And I know Vast has, again, let me know if this is not something that you own, but I know Vast has a CSI plugin, and that would make sense, right, for the shared file system. What about object? Like Cozy, the standard, like we did a podcast like 1.5 years back with the community members, and it was still in the beta stage then, and I think it's still stuck somewhere there. It's not completely GA.
Yeah.
Have you built something of your own that allows you to consume object storage from inside Kubernetes, or how does that work?
Yeah, it's a good question because 2 years ago, we had the same thought. I had looked at the cozy about 2 years ago, and I was really interested in it, and I was hoping it got further along, and I'd be interested to see where it continues to go. But no, we didn't feel that cozy was quite ready, or we didn't really feel that object storage in Kubernetes was at a point where it made a lot of sense. We do have our own object storage offering, which is great, but we don't have it, I guess, natively integrated into Kubernetes, but it is something that we're actively interested in, obviously.
Yeah.
But it's such an interesting space. I'm glad you brought it up because I've been thinking about it for the past few years of like seeing where this will go and like how it can be done really well.
I know. I think at the Paris KubeCon, I saw some talks from the CSI community, like the SIG CSI, SIG storage community, and now they are trying to bring cozy along and make it part of the SIG storage. So I think I'm expecting a bit more progress over the next year than what we saw over the past 2 years.
Yeah, I'll be very interested with that.
Yeah. Okay. Thank you for like going on that tangent with me. So you have been doing this for 2.5 years. I'm sure you have a lot of like long weekends where you were working, or lessons learned, fire, flood, and blood stories. Like, do you mind like sharing any specific lessons you learned and that can be helpful for anybody who's not doing things at this scale, but still trying to adopt Kubernetes inside their own organization?
Yeah. Oh, man. It's one of those things that I think every engineer always hears, that, you don't really know what you know until you do it at scale.
Yep.
And people always ask, well, how do you get to do it at scale? I'm like, well, come join Coreweave or go to another company. But yeah, so, obviously at scale, there's a lot of challenges, right? I think one of the first things that you have to be careful about is your CNI configuration, right?
Yeah.
Especially when you're dealing with multi-region setups, which is not the norm, but it does happen. Obviously any ripple effect in the network could cause an overload or strain on the control plane components, right? So making sure that you have enough capacity on the control plane side, that your API servers are not going to get overloaded, that etcd is not going to, break down and, fail to commit a message or something. Like, these things just ripple, right? I think so when you talk about scale, you have to really make sure you understand where the bottlenecks are going to be, because just because it hits one point, it's going to ripple that effect down, right?
Yeah.
CNI has issues, all like let's say you lose connectivity to a data center, all of your nodes go down. Okay, oh well, now they all come back up. Oh well, now they're thundering, hurting back to the API server. Well, now my API server is down, so then everything else is unhealthy, right? So it's a matter about anticipating what's going to happen, making sure that you identify how all the components interact. And I think a lot of people that run Kubernetes get scared of all the pieces that are needed. But I think if you just take the time to invest in how they play together, and, and I think a lot of people from us, right, because we are a cloud, we run everything on-prem, I've been fortunate enough to be in the weeds on a lot of the networking as well. And I think a lot of people take the networking aspect for granted, because there's a lot involved with Kubernetes networking and understanding how to make it performance, to understand how that plays with your setup, right? And everyone does it a little bit differently. All the clouds have their own networking setups, and there's not much you can do with that, right? But I think if people could take the time to understand how everything plays together, like, okay, like how does, what is Core DNS actually doing? What is the CNI actually doing, right? Like you don't have to be an expert. I don't think anybody needs to go and make code changes to Calico or Cilium or any of these CNIs, but I think it helps, right? The ability to troubleshoot and say, when somebody comes and says, oh, my pod's networking is not working, or I can't hit Google, like, okay, like, it would be nice if you could easily identify, I know what the issue is, right? And I think most of our time as engineers is spent saying, is this really a problem? Or like, where is the problem? Like, because there's nothing worse than just sitting there trying to ask yourself, like, well, what is the issue? This looks fine, right? And I think that's kind of what I've learned a lot in the past 2 years from running at scale, is that, one thing can cause 6 other things to fail, but they're all just side effects, right? And you have to find the root cause.
And I've seen like when people are doing things at scale, right? Observability and monitoring is like this, the key to making sure you can not just monitor your systems, but also help with RCA. Is that like a best practice inside Coreweave? Like anything that gets built in, anything that gets integrated in the stack needs to have this level of observability from scratch, or it doesn't go to production? Is that like a gating factor?
Absolutely. But I think it's really easy for us because we're Kubernetes, right? So we are, we run, the kubeprom stack, right? We have, service monitors for everything, pod monitors for everything, dashboards, all this stuff, right? Alerts. So, thankfully we get a lot of this for free with just the Kubernetes, baked in alerting that you would expect, right? And obviously any custom services, you do your job and create custom metrics for that and things like that. But because we run infrastructure, right, a lot of our alerts are the standard alerts, right? And it's just a matter of making sure that we route them in the appropriate ways. We have the right thresholds for things, because with some of these environments being so finicky, right? Sometimes you're going to get false positives, but like in our case, that's just a matter of us tuning the alerts. But I think we're pretty fortunate that we have such a good ecosystem with Kubernetes that a lot of it's included for us, so we're not having to reinvent the wheel, like I said before, which is really great.
And like, since you brought up CNI, right? And my mind went to how do we handle CVEs? Because I think 2-3 weeks back, Aqua Security released a report where they said FluentBit had some remote execution vulnerability, and this is how you fix it, things like that. So when it comes to Coreweave and Coreweave customers, what does the shared responsibility model looks like? Like, do you monitor for those CVEs, and because it's like more managed experience, and fix it for the customer, or do you forward that information over?
Oh, it's absolutely a shared thing. We if it's part of the stack that we manage, we absolutely will obviously remedy that and take care of that, because our customers expect that from us from a security perspective and a management perspective. If it's not something we directly control, we still are aware. Like, we still have direct monitor of all CVEs, all security concerns. We take, our security is a huge concern at our company. So, if it's something that we don't necessarily run, but we know that someone's running, right? We do say, hey, this is, we've seen this CVE. Will you guys, go fix this, right? And usually it's one of the things like, please fix it or we'll fix it for you type of thing.
I know, but like, you don't want that blast radius to expand outside that one customer, right? Like, you don't want them to get in.
And most customers are going to absolutely fix it, right? No one's going to say, oh, sorry, I want my CVE in my cluster. That's not what you do.
That's a best practice for me, no?
Yeah, exactly. And I think that's what makes our offering a little bit different, right? It's not a black box, right? I can't speak to other what the other hyperscalers doing. I'm sure they have their own tooling, and it's just fine. But because we don't treat it like a black box, we are always well aware of what's going on, in a sense, to help the customer. So we will never let something that looks off, stick around. And I think that's the best way to put it. Like, that's what we think of the shared model responsibility.
Gotcha. Yeah. Okay. Any other lessons learned to share? If not, I can jump into my next question. I didn't want to break you.
No. I think that's kind of it.
Okay, perfect. So what's next for Coreweave, right? You hinted at Knative. Like, are you building anything on top of Kubernetes, or adopting any new CNCF projects? What's the future look like?
Yeah, there's a lot in progress right now. Coreweave is focused on expansion and meeting the needs of the customers, right? And these new GPUs that keep coming out, right? They're bigger, they're better. People are asking for more clusters or more nodes. So we're focused on just getting that experience more streamlined, expanding the scale. We've just expanded into Europe. So we're looking to just make ourselves more available to people that need us. And there are a number of other things we're planning to build to make these experiences better, right? Our managed Kubernetes is only going to continue to get better. A lot of people want to configure certain things, and the more people we bring on, right, the more asks they're going to have, right? I want to configure my audit policy. I want to run this. I want this feature gate, right? And we have our own opinions on some of that stuff, but at the end of the day, like, this is your cluster. Right. So we're going to let you, but we're also going to tell you, hey, what we think is going to work best. Right. Because we're also pretty good users of Kubernetes. So that's what's a little bit different, right? We're not just going to hand you something and say, have fun. We're going to coach you to say, okay, I see what you want, but let me tell you why we think this is better, and kind of work together. And I think that's what's
not just
really cool.
Shipping boxes and like, okay, figure it out. Here are the boxes with GPUs in them, and go have fun.
It's not that. Exactly. It's not that. And that's what's really interesting about building something like this, right? Is it's, and that's what we're focused on building, is like, how do you give someone this really cool, awesome, really flexible sports car, but that they can do anything they want to it, but you should tell them, hey, like, we've made this for you. Like I promise this is going to work like you'd want. So it's, it's a fun relationship to figure out and continue to build.
Gotcha. And before we wrap this up, Brendan, I think I thought of another question. Like I've seen Azure and AWS, those guys having these model garden type of services where they host a lot of models that you can use for as part of your application. Does Coreweave have like a model garden or a registry somewhere that's available to all the customers? And how do people actually get these models on their clusters, right?
Yeah, Corey doesn't host anything like that today. There might be plans in the future, but I can't speak to that. That's a little, that's the other side of the house. I'm sure somebody would be happy to speak to that. But like I said, for people getting models into their clusters today, it depends on the company, right? People either pull from Hugging Face, they do whatever they want. But anything works, right? That's kind of the beauty of it.
Yeah, that's flexibility. Yeah. Like, okay, exactly. Go do your thing.
Yeah, exactly. And obviously we do have opinions. We have things that we know works better than others. And that's why people come to us, because like we have the history of doing these things the right way and like doing it well. But we're not going to tell somebody like, hey, like you can't do this, right? Like that's exactly. We're just going to be like, hey, like this works better. Like trust us. Like.
Gotcha. Okay, let's wrap this up, right? Where can users or people that listen to the podcast go to learn more about a few things, like either what Coreweave is doing in the future? Are they hiring for Kubernetes experts? And do you have like a tech blog where you publish some of these findings and what your team is up to?
Yeah, so if people are interested about Coreweave, you can go to coreweave.com. Obviously, that's our website. You can if you're interested in using Coreweave or if you have a need for GPUs or Kubernetes with GPUs, reach out to our team. They'll be happy to set up a call. If you're interested in jobs, obviously we have, go to our LinkedIn, Coreweave on LinkedIn. We have job postings there. We're always looking for Kubernetes experts who are interested in building more things. I'll be happy to have that conversation with anybody that's interested. So
that's awesome. No, thank you so much, Brandon, for your time today. I know I was excited for this episode and you delivered, man. Like this was a fun discussion. Thank you so much for your time.
Yeah, appreciate it. This was fun. Yeah, thanks.
Okay, that was a great episode. I really liked the level of detail Brandon went into about how they started using Kubernetes 3.5 years back. That was the infrastructure or platform of platform of choice for their cloud rollouts. The discussion around scale was just next level, right? Imagining running 6,000 node bare metal node Kubernetes clusters, and then offering these clusters as a service for people that are running their HPC jobs, that are running their AI model training and model inferencing jobs. I know in the past, in the news section for previous episodes, we have covered like funding rounds and debt financing rounds that Coreweave has raised. Obviously, building out infrastructure is not cheap. But I'm glad that they're doing it and doing it using Kubernetes because that makes it interesting for our ecosystem. Specifically, I like the lessons learned, like making sure observability is part of everything that you do from the beginning instead of trying to bolt on observability. I know usually that applies to security, but like making sure you have observability built in at all layers, making sure you identify where your actual bottlenecks are, not just symptoms that are caused by a specific issue. That was good advice. I'm sure he has some interesting stories off the record to talk about CNI and which CNI and what was the exact issue he faced. But it was interesting to see how they do these things at scale. I like the more managed experience. So like it's not on their users to upgrade Kubernetes. They handle those things for their customers. So overall, a great discussions. I like that they have their own custom OS for the worker nodes that has all the GPU drivers and binaries that are needed, all the NFS provisional binaries that are needed. So overall, a great way to offer Kubernetes as a service. I know not all of us are going to build like hyperscaler based environments, but if you are part of like a platform team that's responsible for offering Kubernetes as a service to your developers or people inside your organization, think about some of these principles, right? Think about if you're doing it on bare metal, what are the different things that you need to think about? Things like Metal LP for service provisioning. If you're doing it on a virtualized platform or just having a front end that eventually deploys EKS, AKS clusters, how do you abstract all of those things away? So think about observability, think about all the different tools, think about the consistency. All of those things will help you have a streamlined experience, hopefully reduce your operational overhead, and allow you to focus on things that actually matter to the business. With that, it brings us to the end of this episode. Before I sign off, I want to make sure that you guys give us a great review on Google Podcast, YouTube, Apple Podcast. Share the link with all of your friends. Join our Slack. You can just go to KubernetesBytes.com for all of our previous episodes, ways to join our Slack channel, find us on all the different platforms. And thank you so much for being a listener. With that, it brings us to the end of today's episode. I'm Bhavin, and thank you for joining another episode of Kubernetes Bytes.
Thank you for listening to the Kubernetes Bytes podcast.